So this is the video where I talk on forever about everything TP3 or the 3-inch toothpick. If you don't want to listen to all of it, there is a table of contents in the description below. Please feel free to skip around. But I am going to just talk freely about the entire class and the history of it and everything and where I'm going and the setups and the components and all that stuff. Starting with the original toothpick. So the concept of the original toothpick was to take already pre-existing components and kind of finagle them in a way that we can use them to build something that is super light, super fun, super durable, super safe, and you can fly it everywhere and it's super enjoyable. And it definitely met all those requirements. However, let's talk about why moving up to 3-inch. So when you go from a 1-inch prop to a 2-inch prop, and then from a 2-inch prop to a 2.5-inch prop, if you look at the physical disc area that you get per prop size, as you go up in prop size, you go up and it starts increasing drastically until you hit 2.5 inch. You get a really drastic increase, sharp vertical line, and then it starts to taper as you go from 2.5 inch and up from there. When you hit 3 inch, it again starts to kind of curve down and taper yet again. So moving from 2 inch to 2.5 inch is a pretty significant jump in disc area. Moving from 2.5 inch to 3 inch is again a significant jump, but not as significant of a jump. Moving up from 3 inch starts to taper more and more. And the reason why disc area is so important is because this is the physical load that you're putting on this disc area. And so having a larger disc area with a lower weight means that you can do more. You can do different things and things perform differently. The main issue that I saw with the original toothpick was that you were really restricted on the amount of weight that you can load onto the platform. Sure, you can load an HD camera, sure you can fly a 200-gram toothpick, sure, all of that works, absolutely. But after you've been flying these things for 5.5, 6 years, you kind of get bored of just things that work, and you're looking for better and better and more and more. And that's kind of the direction where I was heading. And so 73 to 75 grams is really the maximum weight that I have found that you can load an original toothpick on a 2.5 inch little skinny blade and still get really excellent performance out of the quad. Going below 73 grams doesn't give you a whole lot more performance boost. Moving up to 3 inch with the increase in powertrain and everything gives you a little bit more headroom. And so the target weight is really 100 grams, but getting 100 grams is something that's super durable and all this stuff is a little bit difficult. So I've been running things at around 105 grams and I've found really minimal impact to performance. People are loading these things up with HD cameras, obviously, because it can carry it, and they're getting really good performance still out of it. After all, it is a 3-inch quad. It just so happens to be a very low weight 3-inch quad. But I would recommend keeping it below 112 grams all up weight. That includes, holy moly, there is a whole flock of crows all over the place. I'm going to keep talking. Anyways, I'd recommend keeping it below 112 or 115 grams if you can. But if you have to go past that, it doesn't really kill the performance. Now moving on to motors and which ones I prefer. So there are a couple of new motors that are going to be coming out in the 1202 size. I don't recommend 1202 for pretty much anything. I haven't found it to be useful. I've tested about 5 or 6 of them. They're not that great for any category from whooping up. Now that I've scared off all the crows, let's continue. All right, so about motors. There are a couple motors which I don't even have the mint green ones on my quad because they've all been sold. They've been sold out nonstop when they came in. But for the TP3 platform, there are 2 motors that were developed. This is the 1303 motor from Amoxino, which I developed with Amoxino specifically for this purpose, specifically for this Gemfan 3018 prop, to be optimized for everything. Now, of course, I can't test everything, and I haven't done bench testing, although Micromotor Test Lab has done some bench testing on my motors, but I haven't done outright bench testing to compare motors side by side, because bench tests, while very useful, they're really not useful to compare to real world. They're really only useful to compare motors against each other. So in the real world, things feel a little bit different. A motor might make tons of power on the bench, but it may not give you great control in the air. So starting with the 1103 or 11 something size motors, 1103 will run a 3-inch prop totally fine. What you don't get from 1103 is really good throttle fidelity and really great control input response. And that's because, for a number of reasons, but my rationale for, or the way that I explain it, is that the motor physically can't manage the prop easily because there's just too much drag on the blade, or there's too much weight on the blade for the motor to properly manage it. Now, if you think about just motors and the way they're sized out, if you make a motor wider, you're kind of making the prop a little bit smaller compared to the motor because you got a shorter torque lever of that prop. And as you make the motor wider, you kind of gain a lot more power in that width or torque lever arm direction compared to height. Now, height does something a little funny. I've talked about all this stuff extensively. I don't actually know what's going on. I've just kind of come up with these theories and ideas from testing just a whole heap of things. But basically, the 1103 size, in my opinion, to me, doesn't quite feel like you're getting the maximum amount of control and performance and everything. When you move up to 1104 or 1105, it doesn't really make it a whole lot better, but you get a lot more speed out of this thing. And for some reason, 1105 is just unusually efficient at moving very fast on a 3-inch prop. And that's been across a number of 1105s that I've tested. I don't really understand why, but it's just unusually efficient, and many that have tested it, they love 1105 on a 3-inch prop, 3-inch light blade prop. I'm only talking about very light blades, not tri-blades, not quad blades, not heavy things, just a light blade 3-inch. They love it. But I would caution people to go with an 1105 because it doesn't quite give you good control. It just gives you really good speed and throttle performance overall. You don't get good fidelity of the throttle. You just are able to hold the throttle open and go real fast for a surprisingly long amount of time. But again, caution you, because this is really only good for open air environments where there's really nothing to fly around or dodge or not hit. When you start moving up in motor width, you move up to the 12 size, just 1 millimeter makes a really significant difference. Just 1 millimeter more, you start getting a whole heap of control. And this isn't the final motor. The final motor is this mint green color, and it's super cool, super nice. I just don't have any left for myself even because they've all been sold, and I make an effort to get everything out to everybody as fast as I can, and there's more on the way. The 1303s should be in stock right now, but who knows when you're watching this video. But this motor, this is the RCN Power 1204. Now, when I first started with this motor, I actually started with a 1207, and then I went to the 1206, which was the GepRC 1206, and RCN Power actually has a 1206 also. And those, the 1207, 1206 were just really high amp draw, really high amp draw. So I started dropping the stator height and testing them to see if I could maintain the control performance that I want, that I'm getting, and not sacrifice too much speed and everything else that the height gives you. Not speed, but just top-end control performance that the height gives you. And landing on this 1204 happened to be a very nice little medium, and it just so happens that 1303 is 1 millimeter in the other direction, and 1204 is 1 millimeter in the height direction, and both of these motors feel very similar. So now let's compare the 1303 against the 1204. So the 1303 motor definitely has more input control fidelity, as in when you give it inputs, you kind of sort of feel like a little bit, and I say kind of sort of because these two motors are incredibly close. They are so close. You get a little bit more feeling fidelity out of the 1303, and you also get a little bit more throttle control in the lower half of the throttle out of the 1303. The 1204 is still fantastic, and like I said, there is just a hair, a speck of a difference between these two motors. You also get a motor that's a little bit more zippy out of the 1204. Having a motor that has a higher stator height tends to want to zip through the lower RPM range quicker, a little bit quicker, so you don't quite get the same kind of low end or lower 50% throttle fidelity as you might get from the 1303, but you still get all the performance at the top end, and you might get even a touch more high speed control performance from the 1204. Now, you might be asking, why do I need to have good control of the bottom half? Well, if you're a new pilot, you probably haven't recognized yet that going fast is not everything. You actually do need control of your throttle across the range. Now, why is the 1204 in the mint green beautiful color and the 1303 in this black Amoxino color? Because the 1303 is actually a much higher quality motor, much higher quality in the parts, not necessarily in actual function. It is a higher quality motor. It does cost, I think, $1 more. But for that $1, you get a motor that has been engineered kind of heavily to do this task. And not like the 1204 hasn't, but there's been a lot of effort put into this 1303 motor. And the bell itself is actually ribbed like this in order to help cool the magnets. And that apparently, according to the manufacturer, does make a significant difference. That's what they tell me. I'm not convinced that it really does make a huge difference. But in general, the magnet architecture and everything is a generally higher cost structure, so it does cost a little bit more. Now, neither one of these motors have super strong magnets. They actually have somewhat weaker magnets, not the weakest magnets, but weaker magnets, and that's because on these little builds, they're super duper sensitive to noise and feedback into the system. And so when you have really strong magnets, really tight air gap, really great everything, the motor does perform just like 2% better across the board, but you end up having a heap of problems to deal with in the flight controller itself. So there aren't a lot of micro motors, these tiny little motors that are built to a very, very high specification as there are larger motors. And that's not because their manufacturers are trying to save people headache. That's because these motors, when you go to buy a smaller motor, people don't expect to pay more or the same price. They expect to pay less because it's smaller. They think it's littler. But in reality, it doesn't cost less to make. It actually costs a little bit more because it's smaller and more difficult to manage. So compared to a 2207 or a 2306 size motor of $20 valuation, you're going to get a little bit more for your money in the $20 valuation motor. However, both of these motors are made from the hard aluminum, and they're made to very good spec, and people that have tested them have noticed that they are very high quality motors. You may have also noticed that they are both 2mm shaft motors, and that's specifically because the 1.5mm shafts were breaking on even the 65mm toothpick version, which moved up to 2mm just because it's thicker, and also there's no C-clip on top of the shafts on either motor. Some people are very against press fit props, but in reality, the press fit is quite solid on this 2mm shaft, and you have to twist it really good to get it off. And once you do put it on the first time, you have a lot of confidence in this prop shaft, and you feel comfortable running a press fit prop, because out of hundreds of flights, I have only lost one blade to a crash. And so I hope you give that press fit a try. Now, the number of props for this press fit 2mm are limited, and you can drill out props, but drilling out props becomes a little cumbersome. And if you are going to drill out props, I would recommend a reamer type drill rather than just a regular 2mm drill bit, because that's a little bit problematic. Now, I'll talk about the flight performance and what makes it special in a minute, but let me just show you the setup. A lot of people ask for build videos, and there is a video about the frame in the product description, and that's somewhat of a build video because this frame is really, really super simple. I do recognize that there are people that are new to this industry, this field, and are not as well versed in build videos. In builds of things, if people really want a build video, I'll make one, but there's so much help out there. I think that making one general build video may actually be worse than just asking people for customized help, because these things are really not difficult to build, especially in this particular size. The frame is not that difficult to put together. There's a little TPU center in there. I'm going to be doing some updates on the frame. All my products are living, breathing products. They do get updates along the way, so if you do get one later on in its product cycle, you may notice there are a number of updates. The Glide Acro frame has had a number of updates, and the most recent one is for sale on FPV Cycle. And so let's look at the actual construction. So another question that people often ask is, which one do I prefer? Do I prefer the beta board, or do I prefer the, which I didn't even bring it out here, the NamelessRC board? This quad actually has the NamelessRC board. I've used the NamelessRC board more than the beta board, and I've had very good success with the NamelessRC board. I've had one board where the OSD failed. That's it. And the beta board, I just tend to like a little better, really, because it has a gold USB connector, and it has the capacitor already soldered on into the connector, which is just nice and convenient that I don't have to do that. Now, the rest of the build is pretty darn straightforward. You solder your motor wires on. These are 3-phase brushless motors. I'm only saying this for the really new people. Sorry, people that already know this stuff. 3-phase brushless motors. You can solder these motor wires on in whatever order you want. If you flip any 2 wires on the motors, the motor will spin the opposite direction. So if you are setting up your quad and the motor is spinning the wrong way, you can either flip any 2 wires or go into BLHeli, which is another software suite that controls your ESCs, to flip the motor rotation. Now, moving on to the rest of the build, This is the receiver, and the board is laid out in a way that it says everything on the board, so you kind of know where to solder everything on. If you're using a receiver that uses 5 volt, solder to the 5 volt pad. 3.3 volts is pretty much only Spectrum satellite receivers. The S-bus goes on this pad, and I'm just going to leave it at that. The one thing I do want to point out is that my preferred build on this thing is the DVR build. I don't like the split cameras or any of those HD things. I don't think the HD feed is worth it, at least not yet. Maybe you do. I'll talk about that a little bit later, but I'm going to explain my preferred build out of this thing, and I prefer to use a DVR VTX board. Now, this is the Happy Model Diamond DVR VTX board. It's the best option we have today so far. I do have 2 companies working on a new DVR VTX board with another little twist of an additional feature as well, but for now, this is the best option we have. Now, this board is really well laid out. The reliability of the board is not the best, and it does get super ultra hot under function, but it's the best option we have, and I give them kudos to really doing a really nice job laying out the board. So the board has connectors on here, and this connector is the connector that plugs into the flight controller, and the reason why I'm showing it on screen so much is because I want to show you the wire layout, because the wire colors and patterning of the wires is specific and annoying if you don't get it right the first time. So there's ground and voltage, that's obvious. The yellow is actually video out from the camera that goes into the board, and the blue is video into the VTX. So you solder the yellow to the video in on the board and the blue to the video out on the board, and that gives you a pass-through for your VTX on the board. The green is the smart audio, and this does run smart audio. It does not run the tramp protocol. So note that, and if you are setting up your quad, you can use that orientation so you don't make a mistake and do things 10 times over like I do. Anyways, you plug it into this board, then you plug the camera in. Unfortunately, the connector for the camera is not a standard connector. It's actually a much smaller connector. And yeah, it's a much smaller connector. And then you get the camera on top. Now, my preferred camera to this day is the all-in-one whoop cameras. I brought an all-in-one whoop camera here. Yeah, here we go. So I like this whoop camera a lot. Originally, you might think it was terrible, but after testing a heap of cameras, as well as all the Nano cameras on the market, I still prefer this camera. I think it has the best field of view, the best clarity, doesn't have the best light handling, but overall it's a really nice camera. Now there is a Predator camera, Nano Predator coming out, a new version of the Nano Predator coming out that just has a different lens on it. It is a wider field of view lens, and it does tend to look sharper, and it is better. I haven't used it myself. I've seen video of it. It does look really nice. I hope that one takes the cake, but up till now, at this point, this whoop camera is my favorite camera still, and I still think it's the best looking camera. And every time people post videos, other people comment, hey, what camera is that? Looks really nice. This is the standalone version of this whoop camera, and I would be carrying this already in my store. It's about $10, $11. It's great value, except for the fact that there aren't any mounts that fit this darn camera cleanly and easily. So this mount is the B-Brain version 2. Yeah, B-Brain version 2. It is, in my opinion, one of the very best whoop mounts because it weighs 1.3 grams. It's a molded mount. It's surprisingly durable for what it is, and it holds these little whoop all-in-ones really nicely. Unfortunately, this darn camera is too wide to fit into this little thing, so it doesn't really work out for us, and that's really been the hang-up, is that I don't want to sell this camera without a way for people to properly mount it. And yes, there are a number of TPU mounts and all that stuff, but in my opinion, TPU doesn't quite live up to my expectations for a camera mount. I do need it to be a little bit durable. I don't want my camera to smash into my board, into the flight controller board, if I do happen to crash. So my preferred camera mount at this point is actually this thing from Eachine. And so I've been talking to my manufacturers. So this is a molded mount, and it's really, really hard. And it's about 1.7 grams, and that makes it only about half a gram, less than half a gram more than the B-Brain V2 mount. And so this mount is for sale, and I've been asking my suppliers to find a source for this mount because it is an Eachine mount, and while Eachine loves to copy all people from the Western world and people across YouTube, they don't seem to want to share. So I'm still hunting for this mount, and I'm trying to pick it up. Right now, it is available on Banggood, but in my opinion, this is the best mount I've seen for the toothpick to carry a Nano camera just bar none. It's when I first took it out of the thing, it's amazing, and the main reason why I love it is not because of the hard protection, it's because it screws down on all 4 screw mounts, which means that this entire canopy is also structural at the same time, which means it's going to hold the frame together as well as protect and hold your camera, and that just sounds like a fantastic deal to me. So I hope that I can source this mount soon so that I can carry all those Nano cameras and everything across the board on the store as well. Now let's talk about the general setup of the quad and why it performs the way it does. Now, there's nothing that's a secret here, and people that have been doing micros for a long time are generally upset with me because they think that I've stolen something from them and, you know, done something that they think that they've been doing for the past 10 years and I've made it new again or invented it and called it mine. That is the farthest thing from the truth. I'm just like anybody else. I just play with the stuff like anybody else, and I just love to test everything like anybody else. And I'm just fortunate to have access to all the stuff and test everything across the board. And I'm very, very thankful to have these manufacturers' ears to be able to make things for me to be able to test things. So these are the things that come out of all my testing. And I do have a full-time job and a full-time life. So that's really the slowdown of everything. So the formula that I have kind of come across from testing everything, which is, again, not a secret formula, and it's not original, not unique, just something that I've learned from testing that I'm sure many of you already know, is that when you go small, the weight distribution matters a whole lot more than most other things on the quad. Weight distribution and the weight, the all-up weight, are the 2 most important factors of these little tiny micros, in my opinion, in my testing. When you go up to 5-inch, the motors and props and everything gets so darn powerful that you can have a GoPro on a 2-foot arm at the end of your quad and it still will perform fantastically well. Aside from the fact that I don't like the HD split cameras and all that stuff, I specifically don't like them more than the fact that the HD is not worth it and the FPV feed is super compromised and you can't really see much and you can't fly as well as you would be able to fly with a proper FPV camera or this little whoop camera, is because they weigh 10 grams, maybe 12 grams. They don't weigh much anymore, but when you load that weight on top of the frame, you're adding that weight to the height of the quad and you're distributing the weight more on this vertical axis of the quad. And so that means that the motors and the FC and everything need to work harder to manage this extra arm lever of weight out on top of the quad. Another reason why I use these whoop boards, or why I've gone the track of these whoop boards, is because when you use a 16 by 16 stack, again, you get that extra height and you get to put the camera on top of it. And I know it's not a lot of weight, it's just 5-6 grams, but 5-6 grams, that's 5%, 6% of the all-up weight of the quad, and that actually does make a difference. If you were to fly something, one of these things, with an extra 10 grams raised 20 millimeters above the frame, most people would be able to tell the difference. Even if you're a novice, you would be able to tell that, oh, there's something a little off about this one, and that one tends to feel like it's a lot more in control. The reason why the battery is not on top is, again, for the same reason, is because weight distribution. And specifically, an example I would point out is the GepRC Phantom compared to the Emax Tiny Hawk Freestyle. And the main difference between the GepRC Phantom and the Tiny Hawk Freestyle is that the Tiny Hawk Freestyle, they made their own camera and they designed the frame themselves, the FPV camera, and they made it such that the camera sits inside the carbon of the frame. So they were able to drop the top plate height, I think 5 or 6 millimeters on the GepRC. And when you load the battery on top of that quad, compared to the GepRC Phantom, it performs a whole lot better than the Phantom. And that's, in my opinion, maybe I'm wrong, because of the weight distribution. Now, I've also made a number of designs, which I'm not going to show because there are a lot of unique factors of these designs, where the quad is laid out in a lengthwise fashion, where the camera's in front, FC is a little bit further back, or you have a HD camera in the front with the boards in the middle and all that jazz. Those things don't perform well. They just perform awful, just beyond awful. They're just no good. I literally flew them once and I put them in the side of my room and I don't even use them anymore because they perform awful. Those things require much more substantial motors and much more substantial drivetrain to be able to manage all of that extra weight on top of all the stuff. So the battery goes underneath, the camera stays super light, everything stays super light, as low profile as reasonable, because I like things that are reasonable. I don't like doing things that are super crazy and require you to jump through hoops to be able to maintain. Battery goes underneath to keep the center of gravity and the weight distribution super centered, super tight. Now, even though the actual center of gravity is below the prop line, the code has thankfully gotten a lot better, and at this point it's pretty hard to tell the difference on a lightweight quad that has enough power to manage the offset of weight of the battery. It's hard to tell the difference between an under battery and a top battery, even on a 5-inch on a race quad specifically. Not on an acro quad, you can tell because the weight is a little bit higher, but on a race quad, you're talking about 400, 450 grams all up weight, so it's not really a heavy quad, and it's got a ton of power, so it can definitely manage that extra weight swinging underneath the quad, and you don't really feel it all that much. Back in the day, you did feel it quite a bit. And so that's really the main secret of this quad, is the low weight, the tight weight distribution, the 3-inch props. The skinny arms do help to reduce the amount of thrust that gets deflected, and freedom of prop spinning without any ducks and any of that stuff. That's the secret to the toothpick. That's the formula to the Toothpick 3, and that's why it performs the way it does. And there are many quads that sort of follow those guidelines, but they don't quite meet all of the guidelines. So maybe there's designs out there that are better than mine, sure, but hey, this is what I have come up with. I also went with the multi-unit design because I like repairability, and I don't like just breaking my frame and having to move everything over to a new frame. It's just annoying to me. Last but not least, I will also point out this. This is the 3-inch TP3, or whatever it is. It's a 3-inch 1S quad. The all-up weight of this thing is like 40-something grams. Super small, super light. I'm going to be running the, this is a product that's just in testing. I'm working on this with 2 companies to try and get it out the door. I'm not even planning on selling the components because it's just, people want ready-to-fly quads apparently now. Everybody always wants to bind and fly now, and it's incredibly simple to build this thing because you just screw on the motors, plug them into the board, and that's it. It's really nothing else to do on this thing. I guess you have to solder the camera on, but it's got a built-in receiver and all that stuff. This is really preliminary. I've done a lot of testing on this, and there's going to be a lot more testing coming. These motors are not really great motors for the setup, but it is going to have an 1103 motor with probably the 3018 blade, because it is a slightly lower setup or slightly lower load blade than the HQ 3x2, which is also a fantastic blade. I forgot to talk about it, but this video would have been even longer had I talked about everything. And I hope to bring that out sometime soon in the future, and I hope it's going to be, I expect it to be a very reasonable price. Now, one issue with this setup is that weight is absolutely crucial to a 1S quad. Absolutely crucial, more than anything else. And that means you got to use the lightest everything, and this frame is still way too robust for the setup. It flies phenomenally good. It's just incredibly good, way better than the 1S 65mm, but weight, again, is a big concern. So when you go up to 3-inch, you now have the ability to fly for maybe 5 minutes, and it's not slow. It's flying pretty quick for 5 minutes, and you may want to fly far. But unfortunately, if you start adding a receiver on board with the antennas and all that stuff, you now have extra weight on the quad, and it doesn't perform very nicely anymore. Additionally, you may want more than 25 milliwatt video. Again, same problem. So you run into this issue where now you have a fantastic quad that performs lovely on 1S, and it's this beautiful, nice, nimble little thing, and you want to fly it far, and you want to do more with it, but you're restricted by your radio signals. And unfortunately, that's just going to have to be the way it is, because if you want to do 1S, weight is absolutely critical, as well as weight distribution, all that stuff, but weight is the #1 most critical aspect of 1S if you want to do it right, or at least have really good performance. So this will come out, but unfortunately there will also be a heap of people that start complaining about wanting to go farther and wanting to do more, and that's where the TP3 of Toothpick 3 comes in. This thing performs fantastic on 2S, really, really great on 2S, really, really phenomenal on 3S. 450 milliamp cells. Don't use the 300 milliamp cells. They don't last, in my opinion, in my experimentation, in my testing. I don't recommend those 300 milliamp cells at all in 2S, 3S, 4S. Doesn't matter what S they come in, don't recommend them. 450 milliamp 3S is the key battery for this quad. I am going to be having, they're going to be in the FPV Cycle store. We're just waiting for the manufacturer to actually ship the batteries to us, to actually put them in the store. And you can run 450 milliamp 2S as well. That's fantastic as well. I actually like running 450 milliamp 2S for tighter constricted areas because it's just easier to manage the throttle and easier to manage everything. 3S with a throttle cut is also very nice. Lastly, I forgot to talk about the motor KV. So on 3-inch with 3S, 4800 to 5000 kV is the limit. Once you go past 5000 kV with 3S, the RPMs of the motor get, if the motor can actually spin, not like a 1103, a 1204, or a 1303 or something bigger, if it can actually spin the prop up to speed, you start getting flutter in the blade. On the Gemfan 3018 you do, on the HQ 3x2 you do as well. So 5,000 is really what my recommended limit. You can go higher than that, but you're not really going to get a lot for that performance other than, or for that KV, other than extra amp draw. I went with 4,800 kV on the 1303 because I couldn't tell the difference between 4,800 and 5,000 kV. So why spend the extra amps, or the extra amps on the 5,000 kV and just go down to 4,800? Seems to perform just as well. And so the 1303 motor is, 1303 and the 1204 are so darn similar. They are almost exactly the same efficiency. Okay, I think I've talked enough about all this stuff. Ask all the questions you like. There are, thanks for sticking around for this long, if you have stuck around for this long. There are links in the description below, of course. And there's a lot more to come, and I'm going to make more videos on everything as they come along. Oh yeah, one other thing I forgot to talk about is reliability of components. So I waited specifically a couple weeks to make this video because I was waiting to hear back from people that were flying the Beta and the NamelessRC boards. And what we have found so far is that out of several hundred, I don't know how many, not quite 1,000, but several hundred boards sold, we have so far, after 3 weeks or so, had exactly 4 NamelessRC boards that have been faulty or broken or not worked in some way. Either the receiver doesn't pick up signal, or they plug it in and it just smokes out and doesn't work, or they burn out in flight, or they flip out in flight after some percentage of throttle. Those are literally all the 4 issues that people have had so far. And then we've had exactly 3 BetaFPV boards fail. 2 of them caught fire in flight, and 1 of them just did not work. Also, the prototype BetaFPV board that I used did not actually pick up my signal input. So that's the statistics up till this point. There is no board that is statistically significant to be better than another at this point yet. Hopefully they will get better moving forward. Also, BetaFPV has a 20 amp version, which I'm going to be running on a test setup for the Toothpick 5. Yes, I'm crazy. I'm going to go try to make a 5-inch version of the Toothpick. And so I have like a 30-gram frame, and I'm going to be running 1607 or 1507, 1506 motors or something, 1607, something of that size motor. I'm actually thrilled to fly that once again because back in the day I tested a 1407, 1408 on a 5-inch twin blade that was super light, and it wasn't very good. So maybe it'll be a little bit better today with the code and an even reduced weight and a slightly larger motor as well. So it'll be interesting to see where this stuff goes. Take care. Thanks for sticking around this long. Floss your teeth, because flossing is always good. Take care. Bye.